Students, I'm back with a new lecture, and so far we have studied about the design of flexor, in which we have studied about singly reinforced beam. First of all, we started with the introductory portion, the introductory portion of limit state design, the stress strain curve, and then after we have analyzed and designed the types of the beam. There are various types of beams like singly reinforced beam, doubly reinforced beam, and T-beam. So, in all lectures, I have make you understand about all types of beam, the analysis and design of all types of beam. So, and now here you can see one figure. Sorry, I am not so good at the drawing, but I have drawn one structure. In this, the structure shows that this portion is a slab portion. This red portion one is the beam portion. This blue portion one is the column portion. Now, why I have drawn this structure today? Because today we are going to understand about the slab. The another structural element which is slab. Now, why I have drawn this figure? Suppose if some of the people or someone is standing here, okay, and someone is standing here. Now, the slab work in two types. For these people, the upper portion is known as slab, or we can say that ceiling. But the same thing for these people is known as floor. Floor means where we place the tiles, like we place the tiles like this. This type of floor. But the same thing is known as slab also, and the same thing is known as floor also. So slab is also known as ceiling, or second it is known as floor. Okay. Now there are various type of slab. It depends on the support condition, that how the slab is supported. If the slab is supported on two beams, then it is known as one-way slab. Types of support. Based on support condition. First of all, I make you understand and list some types of support. So, it is RCC slab, PCC slab, flat slab. These two are known as solid slab. They are general. We use in conventional slab, flat slab, grid slab, circular slab. But in this portion we will only study about the solid slab. So solid slab are depend on the support condition. The types of solid slab depend on the support condition. Depends on the support condition. Means here it is supported on two beams. This is this side and this side. This side and this side are blank. So if supported on two sides, then it is known as one-way slab. If supported on four sides, means the slab is supported on all sides with the beam. It's supported on four sides. Then it is known as two-way slab. This is depends on the support condition. Two sides, then one-way slab. Four sides, then two-way slab. Another thing. Another thing is based on length, based on size. Because sometimes it is supported on four sides, then also we can consider it as one-way slab. That's how it is possible. So I draw two slab of 2D diagram plan. This one is slab. This one is also slab. This is Ly, means length in y direction. This is Lx, means length in x direction. This is also Ly and this is also Lx. Now, if it is supported on four sides, then how we can make difference in one-way slab and two-way slab? If it is supported on all four sides, then how we can define it as a one-way slab and two-way slab? So if Ly by Lx is greater than or equal to 2, the Ly by Lx is greater than and equal to 2, then it is confirmed as a one-way slab. If Ly by Lx is less than 2, then it is taken as two-way slab. Okay. Generally the two-way slab means a square slab. So what is the difference in one-way slab and two-way slab? In one-way slab, the reinforcement, two types of reinforcement are used in the slab condition. There are two types of reinforcement. First one is main reinforcement. Second one is distribution reinforcement. Okay. So let me make you understand about the main reinforcement and distribution reinforcement. So, the first type we will study is the one-way slab. So I will make you understand about the about the use of reinforcement in the one-way slab. So let me draw one-way slab. With a section. If this is my one-way slab, if I take a section, this one is slab, this is supported on beam. Okay, so the slab, one way slab, this is the shorter direction. LX means it is the shorter direction, and LY means it is the longer direction. In each slab, the longer direction is considered as LY. Okay, so the slab will bend like this in shorter direction. Okay, like this. So the reinforcement, the main reinforcement is used to resist the bending moment. Okay, so the bending moment will be in this direction, shorter direction. So the main reinforcement will be used in shorter direction. Okay, so the main reinforcement will be used like this. For main reinforcement, the alternate bent up bar are used. Which type of bar are used? Alternate bent up bar. So why we use the bent up bar? Have you ever think that why we have used bent up bar and why we bend the bars? So here at the support condition, the shear failure occurs at 45 degree due to tension, due to fixity at 45 degree. So to prevent that cracking, we provide the bent up bar of 45 degree at this stage, like this. Which resists this crack, which resists to fail the slab. Okay, that's why we use bent up bar. And bent up bar are used alternate portion. Means the starting from here, the bend is this and this one goes straight. And from starting here, it will go like this. And this bent up bar is of 45 degree. Okay, it will be always 45 degree because our shear crack occurs at 45 degree. If your house is old, then you can see at the upside that the cracks occurs on the beams and slab. It will be like this, 45 degree. Okay, so we use bent up bar. Okay, and from the front side we can see our bar like this. And the main bars, the main reinforcement will be used of 8 diameter or 10 diameter. Okay, and the another reinforcement is distribution steel, which we use to support the main reinforcement so that the spacing between the main reinforcement can be maintained. That's why we use the distribution steel. The distribution is the straight bar. They aren't main bars. They aren't bent up bars. Okay, they will be like straight bars, like this, and they will be connected with like this. So the spacing between distribution steel and main reinforcement should maintain. And from in plan view, it will be look like this. So like this, the distribution steel are placed, and the distribution steel will be used of 6 diameter. Okay, will be used of 6 diameter. Okay, so the geometry will be like this. This will be the LX from center to center, or clear span. It will be given in the center to center base or in the clear span base. This will be the overall depth of the slab. Okay, So this is our one-way slab. Now the main thing of design is to provide reinforcement. What? The main thing of design is to provide reinforcement. To provide reinforcement. For reinforcement means AST, we need PT, and for PT we need moment. For moment we need load, and for load we need size. So first of all we need to find that how the load or which type of loads are occurring on the slab. So first one is obviously self weight of slab. It means dead load of slab. Second one, as I make you understand in early figure that this is the slab, this is another slab, okay, this is another slab. So for this person, if this one is slab, then this person, this one is floor. For this person, this one is slab, and for this person, this one is floor. So on the floor we provide tiles. So the weight of tiles also will occur on the slab. So it is known as floor finish load. Okay, and the third one will live load. These three loads will occur on the slab. At the time of explanation of steps for calculating the slab, I will explain you each step in the detail. Now I am explaining you, or now I am informing you from the overview side, that what is slab, which type of loads are occur, and how the loads are distributed on the slab. So the distribution of load is depend on the type of slab. If it is one-way slab, then the load will distribute equally this side and this side. If this is B1, beam 1, beam 2, beam 3 and beam 4, then the load will, if there is one-way slab, then the load will only on B2 and B4. None of load will transfer on B1 or B3. Why? Because the main reinforcement is only in the shorter direction. So where the direction of main reinforcement, there will be the load. In two-way slab, the reinforcement are in both sides. So the load will be transferred in the both sides. I will explain you that portion whenever I will teach you the two-way slab. Okay? So today we will only focus on the one-way slab. So this is the overview of one-way slab. Okay? And if I have missed something, then in the next video or in the running time of the lecture, I will make you understand step by step of each thing. Okay? So for today this much only. In the next lecture, I will teach you the calculation or the step for calculating the one-way slab. Okay? Till then, take care. Bye.